So here's the first thing. We've been using a unit circle, and specifically a unit circle, the radius is 1 unit. That's why it's called the unit circle. However, that isn't the only way to measure an angle. You can find the angle no matter what your radius is. So let's pretend we have this drawing, and this is x comma y. The x value travels off to the right, the y value travels up and down, and our radius, r, is the distance away from our center, 0, 0. Right triangle trig is always in effect. It never goes away. We can always fall back on that if everything else is confusing in life. Go back to your right triangles, and we know that a squared plus b squared equals c squared. I'm sorry, x squared plus y squared equals r squared. It's the same thing, Pythagorean theorem. So, if we call this angle theta, and we say that our radius is the square root of x squared plus y squared, we can actually come up with quite a few trig functions using x, y, and r. And these are all equations that we can use to relate them to each other. Okay, so the sine of our angle theta, so opposite over hypotenuse, is y over the radius. Cosine adjacent over hypotenuse is x over the radius. The tangent is just the same as on the unit circle. Opposite over adjacent is y over x. Same rule that we used in our unit circle. And then these are our reciprocal functions. And all we have to do is flip those over. R over y, r over x, and x over y. As long as none of the denominators is equal to 0. Otherwise, if it's a denominator of 0, we get to say that that is undefined. Okay, so we kind of already knew this, right? The only difference is when you're doing unit circle, r always equaled 1. Well, now r doesn't always equal 1. So we're going to have to figure out what the r value is if it's not given to us, and then do our sine, cosine, tangent. So this is just pop quiz. In each quadrant, I want you to write down the trig functions that are positive. So just the positive ones, and include your reciprocal functions. And then check yourself, see how you did. So we're going to be referencing that to make sure that we've got correct values for our sine, cosine, tangent. Okay? Okay. First practice. Name the quadrant where the angle lies if you know that the sine of the angle is positive. If sine of theta is greater than 0, it's positive. And the cosine of theta is negative. What quadrant do we have to be in? So it's all students take calc. Sine is positive, cosine is negative. We're going to land in quadrant 2. Does that make sense? So you should, if I give you that information, you should be able to figure out what quadrant. If I just told you that sine is positive, what are your options? 2 and 1. What if I told you that tangent is positive? 1 and tangent is positive in 3. So it'd be 1 and 3. Okay. So this is a lot like the one we did with our warm-up problem. It says that find the exact value of the 6 trig functions for a positive angle theta if 4, negative 3 is a point on its terminal side. So we graph 4, negative 3, and we connect from the center out to that point. And it's a positive angle, which meant that it traveled around like this. That's our theta. We don't care about that so much as long as we recognize that we've landed in quadrant 4. So it lands in quadrant 4, which means cosine is positive and everything else is negative. So even before I even do anything with any numbers, I could come over here and I know that this is negative, 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 and cosine and secant are positive. I already know that without even looking at numbers. Okay, now I'm going to label my triangle. This is hugely important. Do you remember how we talked about our bow tie angles being our reference angles? When you draw this right triangle, you have to draw the right triangle that uses the reference angle. You cannot draw this one over here. That one is incorrect. It has to be the one that's in pink. So be really careful. I'm going to highlight it. That's the triangle, dropping it to the x-axis. And then label what you know. So this was positive 4 on my x-axis, negative 3 along my y-axis. That makes this a 3, 4, 5 right triangle. And now I can fill in my sine, cosine, tangent. So my sine is opposite over hypotenuse. If I'm thinking about it directionally, since it went down, it's actually negative 3 over my hypotenuse 5. If you're thinking about this as I'm just thinking about my plain old triangle as a 3, 4, 5 right triangle, then I'm remembering this answer is negative, and there's my angle. My sine is opposite over hypotenuse. Either way you think about it, it has to be negative 3/5, final answer. For my cosine, I'm doing my adjacent over my hypotenuse. Tangent is opposite over adjacent. Again, if you're thinking about that as the side length is negative 3 over 4 works out, or if you're just thinking about, oh, tangent in quadrant 4 is negative, either way, it has to be negative 3/4. And then our reciprocals. So negative 5/3, 5/4 is positive, and negative 4/3. By the way, if you put negative 3/5, it's the same as negative 3/5. I don't care where you put the negative. Okay? Whichever you like. Questions before I let you loose on the next one? All right. You do number 3. There's a little twist to this one. Who's ready to check? If you're ready to check, when you get ready to check, wave and I'll put it up. Yeah? Don't look if you're not ready. So these are called reference triangles. And it's a lot like reference angles because using the reference triangle, trig values gives you the same trig values as the angle itself. Did anyone notice what the actual value of this angle is? The reference angle is 45. The actual angle is 135. If you notice that, you might go back to your unit circle values and be like, oh, I know these ones really quick. If you don't notice it, don't worry about it. You can still get it all, but you have to figure out the hypotenuse. So I noticed that this was a 1 square root of 2 ratio. So I did 3 root 2. You could also use the Pythagorean theorem. It takes a little longer, but you get the same answer, 3 root 2. The other tricky part is that you have to reduce your fractions. So you cannot leave 3 over 3 root 2. You have to reduce the fraction and rationalize the denominator. Questions? Okay, compared to the other stuff we've been doing, is this 5 super duper easy? Quiz me on it right now. I totally got this. Or 1, this is way more confusing than any of the other things we've done with the unit circle, and I hate it. So put your hand up. 5, I'm a rock star. 4, 3, 2, okay. We're middling on this one. Got it. We'll practice more. Okay. We're going to skip to example number 6, and then we'll jump back. Because I feel like this ties into what we just did. So, I'm telling you, given cosine of theta equals negative 2/3. I'm telling you cosine. Oh, look, we could even, here, I told you cosine is negative 2/3. I already know cosine. And I'm also telling you that the angle theta is between pi over 2 and pi. So let's think about what quadrant we are. This is 0, pi over 2, pi, 3 pi over 2, 2 pi. If my angle theta is between pi over 2 and pi, that means that we're landing in quadrant 2. So my angle or my reference triangle is going to be in this quadrant, and it always drops to my x-axis. Okay? If I know that my cosine is negative 2/3, I know that opposite over hypotenuse is negative 2/3, which tells me. Wait a minute. Oh yeah. Sorry. My brain stopped functioning. Thank you for saving me from myself. I promise I'll be a better teacher one day. Whew, thank you. Okay, adjacent over. I got over here and I was like, that's not negative 3, right? Like, you can't put negative 3 here. That doesn't make sense. So I knew it had to be. I knew I messed up. So here's negative 3, and then negative 2. Oh my God, you guys. I don't know how you learn anything at all. I try really hard. Okay. So that's my adjacent and my hypotenuse. And now I've got a little right triangle. I can find my missing side. I'm going to call it y because it's a y value, right? So 2 squared plus y squared equals 3 squared. Y squared equals 9 minus 4, or 5. So y is the square root of 5. And that's what I'm going to use over here. Okay, so now that I've got my reference triangle labeled, and I know that cosine is negative and tangent and cotangent are going to be negative, I can fill in my secant. It's 3 over 2 like this. And now I just have to do my other ones. So sine, opposite over hypotenuse, is square root of 5 over 3. Cosecant is my reciprocal, 3 root 5 over 5. Tangent is negative. TOA, opposite over adjacent, is square root of 5 over 2. And cotangent is my reciprocal, so 2 root 5 over 5. Does that make sense? So that one's a little harder because you had to find the missing piece. It didn't just give you the two sides. Okay, we're going to need to finish doing a little bit of those notes tomorrow, but we're in pretty good shape.